Hello, and welcome to our project demonstration for finite element bridge design and graphic user interface. Me and my group mates will now demonstrate how our application works. On the panel here, we can create nodes and we can generate elements. To generate the elements, we enter the node values that we want to generate the element in between. The switch toggles turn on and off the element and node labels. Now, if you were to generate a element that was longer than 3 meters, our system will give you an error as indicated by the red lamp. We have also named our red lamp, but we will mention that later. To get rid of the error, you just simply have to delete the element, and that will fix everything. But you can also upload files for our bridge designer. Like so. The uploaded file will have its weight calculated automatically and displayed on the gauge here. We have a unique feature. This feature is the merge node feature. You can choose 2 nodes, for example, node 9 and 8. And when you click merge nodes, it will simply merge the 2 nodes, as demonstrated in a bit. By merging the nodes, we can further streamline our optimization process and automatically get rid of the redundant elements. To optimize nodes, we can select a single node and decide to optimize it. What the optimization does is that through an iterative process, it moves the node around, finds the maximum score, and outputs the position of the node. It will also move the node there, as demonstrated. Another feature we have that is automated is that we can optimize all nodes while auto-merging nodes that are closer in a certain threshold. If any 2 nodes are closer than 20 centimeters, they will be automatically merged. Like so. You can also control the number of iterations in the optimize all nodes. What this will do is it will go through every single node, find their optimal position, and repeat this process. You can choose how many times this is done. Now, you may have noticed that this lamp here changes colors and texts. We've named this Femlexa. This is our helper. It will tell you when it's computing, it will tell you when there are errors, and it will tell you when it's done computing. You can observe the scores in this gauge here, and you can see the raw score, which should be minimized in the number field there. If you want to know the score, our score more specifically, it is displayed on the label here. The weight has a similar display. It has a more specific display on the number field, and it has a more intuitive display on the number scale here. Now we would like to demonstrate the post-process. After you run the design, as you can see, Femlexa turned yellow to indicate it was still calculating and green when it was done. You can see our post-processing field. You can see the stress distribution and the displacement. You can exaggerate the deformations here. To specifically see the deformation of which node you want, you can enter it here. And as an aesthetic choice, you can also choose the color profiles of the deformation fields. Like so. This is our app, and it can optimize the worst of structures to good structures. Femlexa is an intuitive assistant. The optimization is quick, and the results are effective. Thank you for watching.